Well, hello everyone, and welcome back to Adrian's Digital Basement. This is part 2 in the Samsung S5200 laptop video series. If you haven't seen part 1 already, I recommend you watch that first because this will be a continuation from where I left off in that part. To recap part 1, I grabbed this Samsung S5200 laptop in air quotes, that I have had floating around in the basement for a while, and I wanted to see if I could get it working because I wanted to see what kind of display was in this machine. Well, after some diagnosis and troubleshooting on the power supply, I was able to figure out which components were bad and then bodge in some replacement parts from stuff I had from junk components laying around. And then I was able to finally fire up this computer. And lo and behold, it does have a gas plasma screen. While that's really awesome, the screen is a little worse for wear and unfortunately has a bunch of vertical lines in it, which there were lots of comments from people suggesting that there might be a way to fix the screen by putting the soldering iron and fixing some bond wires, this, that, and the other thing. Not so sure about that, but we can try to figure that out once I get the screen apart and we take a look at the panel itself. Just taking a look at it should reveal the way it's constructed and maybe give us some clues as to ways that it might be fixable. In addition, there are some other issues with this machine that need to be addressed. The 12-volt rail on the motherboard is shorted to ground, so we got to figure that out. I want to disassemble the rest of the computer so we can take a look at the motherboard and see the way it's designed. And then I also want to see if that hard drive is working that's in here. Not to mention, I then want to run a bunch of software on this thing because it does boot up. I want to run some software on here and let's see what the performance is of this machine. How fast is it? I don't know. We'll have to figure that out. So there's lots to do in this video, and without further ado, let's get right to it. All right, we have quite a laundry list of things to work on with this machine. I think I'm going to start by disassembling the machine a little further, getting the hard drive out, and let's see how well this thing works as a computer and see if this hard drive is actually working. Now, when I did power up this computer, I kind of recall that it said it had a bad CMOS battery. So somewhere in here, there's a bad CMOS battery. And if you recall from part 1, there's also a shorted tantalum. So I have the 12-volt rail going to the motherboard disconnected because it won't start if that is connected. So let me try to figure out how exactly to get these components out. I want to get the floppy drive and the hard drive out, and we need to get the keyboard out. We just need to take a look at that PCB so we can try to track down that shorted tantalum. My methodology for disassembling this computer is going to be the same as it was in part 1. It's just simply remove all the screws I can find until things start to come out of the machine. There were 3 brass colored screws along the top edge of the keyboard, and then the keyboard just simply lifts out and it reveals some stuff inside the machine. Let's take a closer look. There is the battery. Luckily, it's one of these self-contained sealed units. Let's get this out of here because this is almost certainly dead. And how interesting that there is a random screw attached to the bottom of the Velcro there. Looks like it was the same type of screws that holds in the hard drive and the floppy drive. Luckily, this high-energy lithium battery did not leak. This is just a normal 3.6-volt battery, so pretty run-of-the-mill, and those are pretty good. They're sealed, and they don't typically leak all over the place, although they can. Looking at the lay of the land here, we have the internal-external switch, the external keyboard connector, PC speaker, 4 SIM slots with 2 megabytes installed, the AMD 12 megahertz 286 processor, space for the numeric processor unit. The machine sports the Chips and Technology PC82C201 chipset, BIOS EEPROMs, keyboard controller, and we have a few crystals and other things under there. Since we're in the area, we have some tantalums right here. Let's just take a look and see if those are shorted. I don't think so. The short's on the 12-volt rail, and almost certainly these are going to be 5-volt. So that one is beeping, but you notice on the multimeter, it's 16 ohms, so that is not a dead short. That's typical for 5 volts. Same there. That one's fine, and that one is fine. So none of these have a dead short, so we're gonna leave those alone. Now for the SCSI hard drive, I took out 4 screws that hold it down. Actually, there were only 2 on the left side, and these 2 were already missing. Perhaps one of these, what was underneath that Velcro. And interesting is the 2 screws that were on the left here were very loose. In fact, they were just barely in there. So perhaps the vibration has loosened those over time and they should have used Loctite. So the hard drive moves a little bit, but it seems like it's still attached over here to this PCB. So perhaps there's a screw that is screwed into the side there. So let's get this power supply module out of here and take a look. Looks like these 2 black screws here are attached to the bracket that hold the hard drive in. So I'm just gonna keep taking screws out until things start falling out. Okay, this should now be free, and it is. I'm removing this SCSI drive from the machine for a couple of reasons. One is my repaired power supply may not be strong enough or have enough current capacity to power this up without blowing components on it. So I will power this off an external power supply, and we can actually hook it up to my bench PC to see if this thing works. And second, I wanted to see if there were any components underneath here that I might need to fix, like those shorted tantalums. But no, as you can see, the PCB edge is right here and there. So there's nothing under the hard drive, only the floppy drive, the keyboard, and there's this video card we're going to have to remove. For the shorted tantalum on this board, I'm pretty sure we're going to find it in one of two places. By the serial port on the back of the machine here, or by this power connector right here, which has some stuff under the floppy drive. So let me get this out next. Okay, floppy drive should pop out. There it is. And let's grab the multimeter here and look around for those shorted tantalums. We have some orange ones here, 3 there. There's another one over here. Let's see what we find. That's it. There's one right there. This one has a dead short, 0.34 ohms. The one next to it is fine. There is one over here by the slots. That one is fine. That one is fine. That's 5-volt rail. 5-volt rail. That's 5 volts as well. That one's 5 volts and good. So the only one that is actually shorted, I think, was the one that's closest here. Yep, right there. I'll just put a little dot on it there to help me identify that that is the culprit, potentially. So let me do a little bit more looking around. I don't think I tested this one over here, did I? This one is fine, no short at all. I'm gonna pop this video card off. It has held in with some plastic standoffs. It may well have a short underneath. What is holding this on? Ah, there's a zip tie there that I cut through, and it's just holding on. There we go. The short might be under here. No, there aren't any tantalums. Well, there's one right there. That could be our culprit. Let's just check it. No, that's on the 5-volt rail, so that's fine. I already tested that one, and it's good. There are some ceramics around here, but I don't think any of those are going to be the problem. They can short, so you do have to watch out for that. For fixing this tantalum, I'm going to take the easy route here. I don't want to remove this entire PCB from the entire case. Seems like a pain. I'm just going to fix this on the top side. So first off, we just need to cut one of the legs here just to see for sure if this is indeed the culprit. Now that this is only connected with one leg, I'll just bend that over and check on the motherboard, and we no longer have a short. So that means the short is definitely in the cap. If I touch the cap leg on the part I cut, yep, that's exactly where the short is. Now, I'm sure there's going to be people in the comment section who can probably explain a lot better about why caps like this short, these tantalum caps. It is unfortunately just a known failure mode of these caps. Now, the good thing is they don't leak, so that's positive, but then the bad thing is they short like this. Now, it seems like these manufacturers, I'm just trying to read the value off this, it seems like these manufacturers use 16-volt caps on things like the 12-volt rail, and I think that's just a little bit too close. If you're going to use tantalums on a 12-volt rail, I think it's better to stick to 25-volt caps. These 16-volt caps on the 5-volt rail, though, are fine. And that seems to be why, at least from my experience, it always seems to be the 12-volt rails that have shorts on them where the 16-volt cap has gone short. I have had a couple motherboards that did have shorted tantalums on the 5-volt rail, but they were the really small little bypass caps used around RAM chips and things like that. I wouldn't be surprised if they used like 6.5-volt tantalums on there to save money. They were always clone motherboards that had this particular short. But those little tiny caps don't have a lot of current capacity, and the power supply just sort of blows them out. So you see little burn marks on them, and then they blow open. So it doesn't actually keep the motherboard from working. Well, I was just trying to read that value of that cap with the loop here, and it slipped out of my fingers, fell on the floor, flew under the desk, or wherever it went. I don't know. You know, when something falls on the floor, it always goes as far away as possible. I don't feel like looking for it. I'm just going to stick something on here to make this computer work again. And by work, well, it's going to work fine with this cap removed and the power supply reconnected. And even with that 12-volt rail disconnected, it still was working. Either way, I'm just going to use this capacitor here. It is 25 volts, 47 microfarad. It's good enough. This is like bulk capacitance for basically the ISA slots and also the serial port. So whatever, it doesn't really matter. The motherboard's not super clearly marked, which is the positive, which is the negative side. There's a little notch right there, and I think this side here is going to be negative. I'm just touching it to the chassis crown, and yep, that's a dead short. So that's our polarity. And there we have it. It's not pretty, but that's going to work perfectly. All right, so I just flipped this computer over, and 2 more screws fell out of it. So that's pretty surprising. There were so many loose screws inside of this thing, and I really don't think anyone's ever opened this up. I also did find a little piece of plastic that fell over here. This is obviously from the hinge on the top cover, which was broken on one side. This whole machine seems relatively well designed. This little piece of metal here has this plastic coating on one side, and this sits, for instance, up here against the card slots so that when the drives are in there and you push on this PCB by plugging in a card or whatever, it won't possibly make contact with the metal hard drive bracket. Little touches like that, they're pretty nice. This is the EGA card I removed from the system. So Paradise EGA chipset, Xilinx CPLD of some type. We have 256K of DRAM. These are 4464 DRAMs. So 2 of these make up 64K by 8. Backside of the board doesn't really have anything on there except a couple of those bodge wires. And yeah, that's all there is to really report here. I am curious if Samsung ever made different video display adapters for this computer. Because there's a 9-pin connector here for the external monitor, they could have had a CGA card that went here, but you couldn't have had something like a VGA card, for instance, because this whole circuitry on the main board would have had to be changed as well. So now that I found and replaced the shorted tantalum, and we've taken out the CMOS battery, the bottom of this computer I think is ready for further testing. But before we do that, let's plug this SCSI hard drive into my test bench, and let's see if this thing even spins, A, and then if I can read it, because if I can read it, I want to copy everything off of this before the hard drive has a chance to die, in case there's any utilities specific for this system that are on this hard drive. And in case you are curious, here's the keyboard removed from the computer. It does say Mitsumi on the back here, so we know who makes this keyboard. We do have a regular PCB backing, and we have what looks like key switches. So this is not a membrane keyboard, which means it should be somewhat reliable and hopefully pretty fixable. Let's try to pop one of these keys off. I can't remember if I did that in part 1 or not. Let's see what we see underneath for a switch type. And there is the switch. I do not recognize that off the top of my head, but I am no keyboard expert. And there is the back of the key. It's relatively thin plastic, very light. It is obviously not double shot, so those are printed on there, although the legends look quite good. They're just a little bit dirty. And these keycaps are obviously made out of PBT because they haven't yellowed at all, except for this space bar, which also has some wear on it. But the rest of the keys, after some cleaning, they should look absolutely mint. The fact that this keyboard also has a microcontroller on it means that the signaling over this is almost certainly just standard PCAT signaling and absolutely nothing special. I'll use my Pentium test bench to try to read the hard drive contents. I have an ISA SCSI card. I'm pretty sure this one does work. I have a couple floating around. Let's try this one first. You know what, just for fun, let's test out this floppy drive while we're at it. This thing has a built-in floppy drive controller. All right, I have the test bench all connected up to the system here. I don't have the hard drive connected to it yet. I just want to make sure I have everything ready to go, because when I power up this hard drive, it may be very short-lived. So I want to make sure I can quickly look at it, get off any files that I can. I mean, I think there's a good chance this hard drive actually will not work. But just in case, I'm all ready to go. First, let's test the floppy drive. The floppy drive is connected up, and what's kind of cool is if we hit A:, it has a red LED. I really kind of like that, actually. Other than the fact that the stepper motor here says Citizen on it, I don't really see any information on like who makes this drive. But if you have one of these machines and the floppy drive does not work, you could just use any old floppy drive, obviously, because, well, clearly it's actually working here hooked up to a normal PC, so standard drives will work fine. So I have that disk in there that's formatted and good, and let's just see if this works. Oh, yep, it's got nothing on it. What I want to do is format this disk with a systems to make it bootable. One little nice curiosity is this drive is very quiet. It's currently formatting the disk, and I do hear it, but it's very subtle, the noise that it's making. And the disk successfully formatted. Excellent. All right, I've reorganized the messy bench here. So floppy drive is still connected with the boot disk in there. SCSI drive is now connected to power and this little short ribbon cable, which goes here into the SCSI card. Let's see what happens. All right, so here we go. I'm gonna hit the power switch. Will the drive spin up? It did. It's noisy, but it freaking spun immediately. So let's see if it's detected here by the Adaptec BIOS. Oh, it sounds good. I mean, it's noisy, but it's making normal SCSI disk sounds. Here we go. It's gonna come up in a second, everyone. This will be real time. Will it work or will it not work? Come on. Yes, there we go. SCSI ID 0. What did we boot off of? Is this my compact flash card? Yes. So it said the D drive is the SCSI drive. Let's see. Oh no. Is that really the SCSI drive? It's blank. That's super disappointing. Here's the E drive. This is definitely my compact flash card. Let's go to F disk. Let's see what we see here. So here we are in F disk. Let's see what we see. So partition tables. This is absolutely my compact flash card because it's got extended partition on it and whatever. Okay, yep. Change disk to number 2. So it's only a 30 meg hard drive? That's pretty ridiculously small, isn't it? There it is, 31 megabytes. It is showing up as the D drive right now, and the D drive has absolutely nothing on it. What a freaking shame that is. I gotta keep my fingers crossed here. That Samsung laptop has like a built-in BIOS that you can go into that's built into the ROMs, because if the utilities on that thing are disk-based, we're completely up a creek. There are no disks available for this thing. There is no information available for it. The only thing I can think of here is I'm gonna look around for a DOS utility that can try to unformat a hard drive. Maybe whoever did this format just did a quick format and it didn't rewrite the entire hard drive, so we could try to get back some of the lost files. All right, so I rebooted the system here. Let's see if we can still see the hard drive. We can. First off, there is an unformat command in DOS. So let's try this. Restores the area. I've never tried to use this actually ever before. I think this tool only really works if you use DOS 622 to format the hard drive in the first place, and then it saves a backup copy of the file allocation table, and that's what it's currently looking for, which this hopefully will restore. The DOS 622 unformat utility finished scanning this hard drive and it didn't find any kind of information on, well, that enabled it to unformat the drive. So what I went ahead and did is I connected this up to my SCSI laptop that was sent in by a viewer on a previous mail call, and I imaged this into a file because I wanted to look with a hex editor to see if this drive even contains any information that's worth unformatting. If the entire drive had been blanked out, then there's no information to recover. And taking a gander at the contents of this drive here, this is the very beginning of the drive, and this just seems like standard stuff here for DOS. Looks like a bunch of 6Cs were written to the drive here. Let's keep scrolling down. We have some information. So MS-DOS 5.0. This might be the command com from the DOS that we saw when we did a DIR on the drive. That's probably what we're looking at here. So MS-DOS 5.0. But let's keep scrolling down. Look at this, everyone. Right here, we can see that there's contents on the drive. So this looks like a file allocation table, defrag, double space. Maybe it's not a FAT listing, but it's a directory listing of some kind. Not sure if these are blank entries or something here. All right, well, I'd say that there's actually some data that's still on this drive here. And of course, it's imaged now, so even if that SCSI hard drive dies, we still have access to it. Question is, let's do a search and let's put in the word Samsung, because we know if there's any utilities on here, maybe they say Samsung in them. Aha, look, here is one right here. Samsung Semiconductor and Telecommunications Company Limited, 1987-88, GW Basic. Yeah, it looks like they had a customized version of DOS on here with a customized version of BASIC. These two look identical, and they are in two different spots on the disk, so maybe there's two copies of GW Basic. And this third one here, oh look, S5200 Laptop Palette Program version 1.2 or 1.3. Palette Program is now resident. To activate, menu type Alt, and it looks like the little tilde key to change palette or change display. All right, so maybe what this utility does is designed for the plasma screen to switch around the palettes to make it more readable depending on the graphics that you have displayed. And this is obviously a terminate and stay resident or TSR program for DOS. Let's see if we have S5200 anywhere else on this machine. Nah, we just have that one instance of it. Looking around through more of the hard drive, looks like Windows 286 3.0 was installed on this machine. This here looks like we're looking at config.sys, and here's something that's bad. Double space. Does that mean that makes recovery of data that much more difficult because double space compresses everything? And oh yeah, that's not good. And this looks like the autoexec.bat. Looks like there's just a couple of normal utilities, but there's also that palette.exe, I guess it's palette.exe, is set up to run in here. I've definitely confirmed that there is some usable, potentially usable information inside this hard drive image that I've made that's from this original drive. A couple utilities that are for the S5200 that we may want to try to extract. So I'm asking for help. If anyone has any thoughts and ideas about how to do data recovery off this hard drive image, definitely please let me know. I don't want to post this hard drive image up on somewhere like archive.org because it does look like there is some personal information in here. So I don't want that stuff to just be floating around on the internet for all time. I think it's now time to clear off the bench and bring that thing back and get it hooked up to an RGB to HDMI. Let's see exactly what that computer can do. And I'm pointing down there because it's sitting on the floor right next to me. All right, so this thing is partially reassembled. I put the floppy drive back in. I put the hard drive bracket back in, minus the hard drive. I'm not going to reinstall that. But I did keep the screws there. For booting up this system, I'm going to use this, the XT IDE, and that's because I don't know if the SCSI controller that's built into this has the same base I/O address as a normal IDE controller. Otherwise, I would install a 16-bit ISA controller into this machine. But for now, we're better off using this 8-bit card since this uses a different base I/O than the SCSI controller that's in here and any IDE interface. This will have the best chance of actually working. The power supply will sit right here on top of the cards, and I am a little bit afraid that this metal here might touch this card because I'm missing part of the structure for the power supply, the top cover, which actually strengthens and raises up the power supply in this area. So because of that, I'm just going to stick this piece of plastic on top of the XT IDE card just to be safe. I went ahead and I reinstalled the yellow wire into the connector. This was the 12-volt rail that was shorting because of that bad tantalum capacitor, which we've now fixed. I also went ahead and reconnected the power cable on the floppy drive. We're just gonna risk it and hopefully not blow anything up. We'll just make sure that's sitting in the right spot there. And with all of that, we're ready for some bench testing of the S5200. I'll get to that screen and trying to see if I can repair it, but for now, I'm just gonna plug this into the RGB to HDMI through the EGA connector, and we'll use it with an external monitor. This cable here goes to the RGB to HDMI, and I can only hope that this thing outputs EGA video at the same time as trying to drive the panel. If we have to go into the BIOS to try to change an option, or there was a disk utility or something that we don't have, well, we're kind of up a creek at that point. I have the RGB to HDMI configured for EGA. Let's just turn on the auto switch mode down here. Plug in the power, and it turned on. The switch was already on, and look, we're already getting output. Sweet, so that freaking works. All right, well, battery's not connected, it runs setup. Please tell me that setup is something that we can actually run. I'm pushing F keys here. F1 to continue, or, oh, Control Alt Escape for setup. I think I missed that, hitting Control Alt Escape. Oh wait, there it was, it worked. I was saying it was going to the SCSI BIOS to try to find a hard drive. Let's try this again. Okay, there we go. We are in the setup utility. It is built into this thing, and that is awesome. We'll set a random date and time to something other than the blank that was in there. Diskette type, we'll set this to 1.4 megabytes. It looks like it supports the normal hard drive types, which is interesting because when you have SCSI, you don't need that. I figured that these are custom types, but it doesn't seem like there's any way to type in heads and cylinders. That means that you would need to edit the BIOS file itself if you wanted to create custom types for your specific hard drive. Looks like we have a few different settings here for the type of screen. Of course, we'll leave this on EGA. Base memory 640, extended memory. We know we have 2 megabytes of RAM because we saw those 2 memory modules that were down here under the keyboard. And we can change this to halt on errors. It doesn't really matter. It's going to lose all these settings anyways. F2 for color. Ooh, look at those colors. Yellow and blue. F10 to record settings. As I was saying though, we have no battery in here right now. I could just plug one into that header, but for now it's just gonna lose those settings as soon as it tries to start to boot. Hopefully, once it shows the SCSI BIOS, it then goes to try to boot off of the XT IDE card. Let's see what happens. There still could be a conflict though, so it may not work, but I should be able to figure that out if there is a conflict. So while we wait for it to scan the SCSI drives, what is cool here is that we know that this thing can work as a headless 286 machine. So theoretically, if the plasma screen never works, well, I could just reassemble this thing without the screen installed, and we'd have a very portable and transportable 286 machine. And the fact is, you can actually put a Sound Blaster card in here because we have normal ISA slots. And yeah, failed. Okay, whatever. We're just gonna hit F1 and hopefully we see, okay, we're not getting, and it just rebooted. That means that there's probably a conflict between the XT IDE BIOS, the address that it's set to, and the internal SCSI drive. That's okay. Let's boot a floppy disk here that has check it on it, and that should give us the insight into where exactly the ROM BIOS for the SCSI controller sits in memory. It is actually booting DOS 622 off the floppy disk. There it is, starting MS-DOS, and this disk should have check it on here. Yes, it does. Check it. So I fully expect this computer to be a bog standard 286 running at 12 megahertz. It is cool, it can support up to 4 megs of RAM, so that's a bonus, but I don't really expect anything else special about this machine, including the fact it's probably running at 1 wait state. We should be able to figure that out in just a moment. It does show the BIOS here as an Award BIOS, even though it has a Samsung brand on it. I guess they just bought it from Award. So far, everything is as expected. We have 2 COM ports available, we have a CMOS clock, and we have EGA video and 2 megabytes of memory. Looking here in the memory map, we do have a few adapter ROMs. So we have one that starts at E1000 Samsung Electric. Maybe that's the SCSI BIOS. We have an unknown ROM, Award software. That's interesting. That's starting at E800. And then here at F1000, we have another Samsung ROM. And it looks like F4 as well. So this is the Award BIOS as well. So there's a bunch of stuff in here. I'm pretty sure this XT IDE card here is configured for C800 here. And yet it didn't show up, and it's not showing up in here either. Taking a look in the benchmarks here, it shows that it's running at 8 megahertz. That's kind of slow, so I wonder if there's a way to speed it up into turbo mode using a DOS utility that we don't have. Unfortunately, the keyboard here has no silkscreen markings for any kind of like key combinations to speed the machine up. Sometimes though, Control, Alt, and plus, it made a beep. That can speed things up. So this thing here shows that the clock speed again is 7.986 megahertz, so 8 megahertz, but the CPU effective speed is 9 megahertz. I don't know if that means we're at 0 wait states or 1 wait state for the memory, but either way, it's only slightly faster than a 5170 would with this same program. And we have video speed of 484 characters per millisecond, which is quite slow, but I think also typical for EGA. Let's try some key combinations to speed things up. So Control Alt plus on the numeric keypad, minus plus. Yeah, so far, Control Shift, Control Alt 8, Control Alt. I'm just hitting Control Alt and a bunch of different numbers here to see if anything speeds this up, but does not seem to be the case. This kind of tells us that this computer either just runs at 8 megahertz all the time, and it's not any faster than that, which kind of sucks actually, or the turbo mode is just available through a DOS utility or some other keyboard combo that I just don't happen to know. It was Control Alt Escape that took us into the BIOS setup, but it doesn't seem to be doing that here in DOS. Let's just reboot. I just want to check one more time that there wasn't a turbo thing in there that I just missed because I wasn't really paying attention. So here we go, modular BIOS, S5200, Control Alt Escape. Oh, speed select, it's right there at the bottom. Honestly, arrows to change between the value. There it is, high and low. It was right there the entire time. F10 to save and F5 to boot. Before we let this thing boot up all the way though, let's just power this off. And I want to check the XT IDE card just to see the memory address of it. All right, looking here at the switches, looks like this is actually configured for D800. So we're going to change that to off, on, off, off. So A16 just needs to change to off. And now this is going to be C800. And this should actually work, hopefully. Okay, round 2. Hopefully this is working now. And really, I just want to do this because I want to run some software and don't want to boot off a floppy disk for everything. It's kind of inconvenient. Looks like the machine preserved its BIOS settings even with no battery, having it off for a couple minutes. That's not super unusual. You can usually get a couple minutes even without a battery installed. Oh, it's still not working though. That is weird. Why? It's quite possible the BIOS that's on here does not support option ROMs. The fact is the SCSI BIOS here, which we see there, is an option ROM. And it might be the only one that it looks to, and it just ignores everything else that's in the system. I gotta say that this fan that's on the power supply is annoying. I'm just gonna unplug that because it's not really doing anything without the cover on here anyways, and yeah, it just makes a bunch of noise. Well, here in the memory map, we do not see a BIOS ROM at C800. That means that the XDID card maybe is not making a good connection in the slot, or there's some other issue here. And that seems to be a problem with Check It actually, because in debug, looking at C800, there it is, XT IDE Universal BIOS. So unfortunately, that means that this BIOS on the motherboard does not support option ROMs. That means there's no way to get an XT IDE card working, which gives us only one choice, using a SCSI emulator for hard drives. What we can do is, now that the machine is set for fast mode in the BIOS, let's check out landmark speed test here. If we're getting 14 megahertz, 13 megahertz. Yeah, so I don't think 13.8 megahertz. That's interesting. I was gonna say if it's like 14-ish megahertz, that means usually you're at 0 wait states for the DRAM. So maybe this thing's running at 0 wait states. I'm not quite sure. Either way, this computer is running as good as it's gonna run, as fast as it's gonna run. So let me get a hard drive hooked up to this thing so we can boot up and actually run a little bit of software on this, put it through its paces. What I decided to do for the hard drive is, well, figured it was as good a time as any to finally open the package that Joe over at Joe's Computer Museum sent in. And he sent me a couple BlueSCSIs to try out. These are the newer versions. And I have to say, I haven't used them before, but this project is very, very impressive. As you can see by this internal version here, this has a Raspberry Pi Pico on it, the wireless version, an SD card slot, SCSI connector, and a power connector. And this one from Joe includes 3D printed bracket, so this can actually be screwed into the case if you want to keep it inside permanently. This one right here is an external version that is designed to plug into machines that have a 25-pin connector, so Macintoshes really come to mind. Now this has the same setup inside with a Raspberry Pi Pico, and you stick your micro SD card over here on this side, but it's a nice little self-contained, self-powered unit that can just plug straight into the back of the machine. If you ever have a need for SCSI devices and you haven't looked at the BlueSCSI before, I highly recommend you do that. What's awesome about this project is it's open source and they keep adding new capabilities and new functionality to these devices. And of course, since it's open source, you can download the Gerbers and have your own PCBs made and make your own, or you can buy these fully assembled versions like Joe sells on his store. I'll put a link in the description below. What's really cool about the BlueSCSI, these later versions at least, is wide and varied support for all sorts of types of SCSI devices, and it's very easy to get going. All you have to do is stick an SD card in the unit and you just name the files. You have like hard drive images or ISOs if you're talking about CDs. You just name the files appropriately for the SCSI ID and the LUN, the logical unit number, if your system uses that. And obviously you can see this list here: hard drive, optical, floppy support. Yes, SCSI floppy support. There's magneto-optical support, removable drive support, so like SideQuest type drives, and tape drives as well. But there's actually more. The Wi-Fi versions of these BlueSCSI support this Dynaport SCSI Ethernet adapter. It was something that existed for Macintoshes back in the day. It plugged into your SCSI port and it got your Macintosh on the network. Well, this Dynaport emulation for the BlueSCSI can use the Wi-Fi adapter that's on the Raspberry Pi Pico to actually get your system online through the SCSI port. As far as I'm aware, there are only drivers for the Macintosh, although maybe Amiga ones exist. I'm not too sure. I've never actually used a real Dynaport or the emulation for this. Now, this machine here obviously has a SCSI controller in it, but there's no way it could support Ethernet over SCSI, not without some kind of custom firmware on the motherboard of this Samsung laptop. So with this thing, we're just going to use the bone stock hard drive emulation. And what I went ahead and did is I just copied the hard drive image I made from the original Seagate drive onto the SD card here, and I assigned it as SCSI ID 0. I figured that's a really good place to start because I knew that that particular drive worked in this system. And I'm worried that if I use larger images like my compact flash card, which is like a 4 gig card, that might be too big for the SCSI controller that's in this machine. We have to remember that this computer is from the 80s and there were no big hard drives back then. So this little 30 meg hard drive image might be a good place to start just to see if the whole SCSI interface on this machine is working. Joe sent along this little starter sheet here for the BlueSCSI version 2. And that just gives you the cheat sheet on how to rename the files and stuff. It's the same information that's on the web page. And look, it even talks about the Wi-Fi functionality. Freaking awesome. This little external version of the BlueSCSI kind of reminds me of the fact that this machine, while it has SCSI, it does not have an external SCSI connector. Isn't the whole point of having SCSI on a computer the expandability that it gives you, the ability to plug in external hard drives very easily? So I find it really curious that Samsung decided to put SCSI on this, and they spent the extra expense to do that. And then what? They didn't even give you the ability to plug in external hard drives, which kind of would have been a killer app for this. If you were at home and docked, you could plug in external hard drives, external CD-ROMs or whatever. And then when you go on the road with your laptop, you pull those cables off the back and then you go and do mobile computing with your like 30-pound laptop. Anyhow, let's give this thing a try. Let's see what happens here. So one thing I noticed is this computer was turned off for a while, as in I went up and had dinner, I was like clearing some snow away from the driveway, and there's no battery in here, and yet it seems that the BIOS has not lost any of its settings. Okay, starting MS-DOS. Now when we looked at this hard drive image, there was nothing. what's happening here? Because we looked at the hard drive image. I'm at a loss for words right now. When we looked at the hard drive plugged into my Adaptec SCSI controller on my Pentium system, we didn't see anything on here except just a single command.com file. And yet, what is this? Oh, wait a second, everyone. Wait a second. Drive space. We saw evidence that this thing was using double space or drive space or whatever that thing was called. And I think the way that works is the hard drive itself, when you're looking at it on a different system, you don't see anything because the entire file system is compressed into some kind of a container file. And that's what threw me for a loop. And it's funny because why did we, when we were doing the hex editor, we saw like the contents of some files as if they weren't compressed. But I guess this thing is using drive space because there's stuff on here. There is freaking stuff on here. Okay, well, I'm really glad that I just decided to start with that hard drive image that I made off the physical drive and put that on the BlueSCSI because, well, I don't know, I probably would have never figured it out. I suppose one of my viewers would have commented, actually now I think about it, to say like, oh, it has drive space, and that's what it would look like when you look at a drive space disk. So I just, it's been a long time since I've touched drive space or even thought about drive space. Or is it double space? I forgot. Drive space, what is the command? No, it's double space, isn't it? Yeah, it's double space. Okay. So there it is, compressed hard drive, total space, 40 megabytes. Like this is something that Microsoft added to MS-DOS like 6.2, which I guess is what this is running. How do we get out of here? Drive, exit. Red background is weird, but did you notice the auto exec had that palette command, that's the Samsung S5200 thing, and it seemed to switch to this red mode. Can we run that right here? Yeah, that's it there. So activate menu, this, okay, escape. Oh, okay. Well, you know, I'm wondering if that menu, whatever this is, appears on the gas plasma screen. Oh, I think I was actually pushing Alt and tilde, not Control. So that's Alt. So you push it once, push it twice, it goes back and forth. So that must be toggling between the external and the input display. And then if I push Control and push tilde, that gives us nothing. So I'm assuming, yeah, it's displaying some kind of a menu on the other screen. Okay, so a couple quick observations. The BlueSCSI works on a Samsung S5200. It's probably the very first time ever in history that someone has run a BlueSCSI with a Raspberry Pi Pico on this particular computer. You can add it to your compatibility list of machines that are supported Samsung S5200. I'm just going to copy some of my utilities onto the hard drive so we can just poke around a little bit and see what we see. I like to use this utility called HDIR. I think it's Hot Directory 1.1, and it just displays the directory in a much more user-friendly format. As you can see right there, I just copied that into the DOS directory. So now if we do HDIR, we can kind of look at what's on this hard drive a little bit. So right off the bat, you can see that there's a Windows directory. So let's run Windows. I think this should be Windows 3.0 286. Yes, it is. Ignore the weird aspect ratio, by the way. That's just because this is running in VGA or EGA resolution, which is 640 by 350. So the number of lines is less than VGA, so everything's going to look a little elongated compared to what you might be used to when you're looking at Windows in 640 by 480. Okay, well, there's like all sorts of stuff here. I don't have a mouse plugged in, but this looks like it was definitely used for business purposes. We have Quick Into for Windows, Professional Write, so some kind of word processor, Microsoft Works, and ACPAC Plus, which is what? Is that financial software? Let's run that. It's a DOS program as well. ACPAC Plus Windowing System Manager. And look at that, we have some general ledgers in there. I'm going to open one of these, but I'm not going to show it because there's who knows what kind of personal and company information in here. All right, poking around in here, there is actual data typed in there. I see addresses and financial information and stuff, so I am definitely gonna be exiting out of here and I won't be keeping any of this information. We can see clearly with the way the program manager is set up here that this was absolutely used as a business computer and nothing more. There's all sorts of stuff for like restoring and backup files and things like that. We do have to go check out the games though. Okay, yeah, there's not even any games on here except for just the two that were included with Windows. And poking around this hard drive in DOS reveals, well, exactly the same thing. It's just strictly business stuff, and that's it. Now, it appears that any of the Samsung specific utilities are here in the DOS directory. And you can see the palette command up on the top right. I'm gonna have to kind of poke around through this stuff here and just try to figure out which of the things here are specific to this. I think GW Basic was one that was also an older or specific version for this machine. Doesn't say anything about Samsung there though. One way we might be able to pick out which files aren't just part of the normal DOS directory is sorting the file order by date. And it's going to put the earliest first. So HDIR I copied in there. Basic and Basic A, those are from 87. So yes, this stuff here, this stuff looks really old. So there's the palette command and PCK key, whatever that is. And then we have LL3, that's from 1990. And then we have some basic programs from 1991, along with this stuff, but this is obviously just regular MS-DOS. So you see the date there. That must have been some particular version of DOS that was on here. Maybe it was upgraded to MS-DOS 6 dot whatever. Oh, okay, you look at the time. See how it's 5? That would be MS-DOS 5, and now it's 6. And I think that's version 6 of DOS. And you can see all the commands there, all have the same exact date as well. Oh, and then 6.2. Okay, so this thing's had several versions of DOS on here. I assume we're on 6.2.0 right now. So, yep, it's been updated along the way. So let's check out a couple of these programs. What's this PCK key? Keyboard Accelerator, PC Quick. This seems like some kind of a third-party utility just to speed up the keyboard repeat rate. Or not. Yeah, that is definitely faster than it was. Wow, the delay time. Oh, one thing I noticed is that the keys don't work super well. Like sometimes I go to push the delete key and it doesn't register. I have to push it harder, or the enter key is the same thing. Probably as I'm using it now, it's kind of coming good. It's getting better, but definitely initially it was like missing key presses pretty frequently. LL3, I think is a DOS 3.3 utility of some kind. Oh, LapLink. No, this is not a DOS utility. So this would be transferring files over the serial cable, or parallel, I suppose, between two machines. So maybe that was their way of getting stuff on and off this machine. Perhaps they were using LapLink to make backups of the data that's on this thing. So in case the SCSI hard drive crashed, which it didn't, it still works. They would have had their files still. I'm just wondering if Basic or Basic A has anything to do with Samsung, and it doesn't seem to, that's for sure. So it seems like palette's the only actual thing that comes up that is Samsung specific. So I will copy that onto this floppy disk here just so I can get it off this machine, and we can archive that. I'll upload it to archive.org. And I think that is actually it for this machine. So what I'm going to do is pop the SD card out here, and I'm going to try to use an image on this of my larger compact flash card. Let's see if that works. And just like I feared, the 4 gig image of my, well, build bench PC, which has like all the games and stuff on it, it was too big for this computer to support. It didn't, well, it would detect a hard drive, but then it wouldn't boot. And if I booted the system off a floppy drive and it went to F disk, it didn't even see a hard drive. So I think 4 gigabytes is too much for this card. I don't really know the limit. It might be something more like 2 gigabytes. I'll try to make a smaller image, like maybe a 1 gig image using WinImage, and let's see if we can get that working. Well, after much fiddling around, I really couldn't get, well, any other hard drive images working except for that 31 megabyte image from the Seagate hard drive. So I ended up just copying 2 copies of that image onto the SD card as ID 0 and ID 1. So there are 2 hard drives in this machine now. I just formatted both of them, and then I copied some files onto those 2 images using my Windows 10 PC. So here we are running Jim Leonard's Top Bench. Let's see what this thing benchmarks at. Probably the first time ever that this program has ever been run on the Samsung S5200. And there we go, we get a score of 18. At least this computer is faster than the IBM PC XT286. Although I've talked to Jim about this a little bit. So when you run benchmarks with this program, it's a total benchmark where it takes into account the memory speed, the processor speed, and the video memory speed as well. So if you have a very slow video card on a very fast computer, it's actually going to give you a total score that's a lot slower than one of the other systems. I thought it would be neat if we could set this program to exclude the video card, for instance, when it was comparing against other machines. So it was truly only looking at the RAM and the CPU for speed comparison. But right now it's not possible. So, well, this machine's as fast as a PS2 Model 50. So next up, I ran the program VidSpeed, which just does a performance test on the video card. And it runs through all the video modes when you use the parameters star and plus. And it shows you right off the bat, if you look at these results here, that the RAM speed of this thing can go about 7.6K per millisecond. And the video card is essentially, well, 1/10 the speed. It's worse than 1/10 the speed of that. When you look at normal VGA cards that are good performance, you typically can see up to 1,800 or 2,000 bytes per millisecond on those cards. Now, what's really interesting on this card, though, is look at some of those resolutions that this thing supports. 640 by 480 by 16 colors and 640 by 480 by 2 colors. So this must be some kind of like weird custom paradise mode that I guess it supports, that allows up to 350 lines of resolution when EGA normally ever only supports 350. And it can jump down to the 200 line modes, which is CGA compatibility as needed. And EGA adapters can also output a CGA type signal, which is compatible with CGA monitors, but also EGA monitors can sync to either of those frequencies. But no EGA monitor supports 640 by 480 out of the box, at least. I'm going to use Jim Leonard's ROM dumping utility here to dump the ROMs that are found on this machine, and I'll copy these and upload these as well to archive.org. So here on the second hard drive, or the D drive, I've copied over a few games. So let's see how these run on this machine. I'm expecting them to run, well, exactly like any other EGA 286. And when plugged into the RGB to HDMI are going to look good. We'll have to try them later with the plasma display and just see, well, how not so great it might look there. First off, we have Outrun, which the DOS version of Outrun is an EGA game. It looks decently good, although it only supports the beep speaker, not even any ad-lib support at all. Let's see how I can get this started here. 1989, oh, it's about the same era as this computer as well. It's funny, as it's loading, oh, it's so slow. Oh, okay. It's not horrible. Now, one thing interesting about this game is while it's from 1989, it does work fine on really fast computers. Now, you don't get like incredible frame rates, but the speed of the gameplay actually is fine. You'll get better frame rates than this, but you're stuck with PC beep speaker, which at least plays, you know, in the background here. There is no sound effects either, so no engine noises, no nothing. And you know, it's not terrible, the performance, but it's also not really that great either. Now, what I wonder is when we actually hook up the plasma screen and we run that game, 320 by 200 line games might end up looking squished with bars on the top and bottom because the panel probably has a native resolution of 350 lines. And it's not like there was any kind of scaling back in the day in the 80s. So it's just going to display with the bars on the top and bottom. Okay, next up we have Attack of the Petsky Robots, or PC Robots. It's a David Murray's game. Someone mentioned that this particular chipset that's on here, this Paradise chipset, supports the Plantronics modes. So let's just give that a try. So 7 for Plantronics. We'll just skip the sound for now. No, it does not support Plantronics. So Plantronics mode just have extra planes. So when you have a card that's compatible with Plantronics, you will get a full 16 colors, which are the same 16 colors you'll get in EGA graphics anyway. So there's really no reason to use it. Although there might be a few games out there that do support Plantronics and they do not support EGA. So that might be a good way to get that enhanced 16 color. If we run robots again though, and we pick EGA this time, and let's see, sound device, music device, this will give us the 16 colors. And there it is. Performance of the game, yeah, it's pretty good as well. Now, one of the things I find interesting about this particular game that David Murray decided not to do, and if we exit out of here, I want to show his other game. When we run Planet X3 in EGA mode, something really interesting happens with this game that I've actually never really seen with any other game. Look how freaking fantastic the splash screen looks there. What David did is he took the VGA assets, so 320 by 200 assets, 256 colors, and he renders those in EGA mode at 640 by 200, but he uses dithering. When you take the normal 16 EGA colors and you dither them, so you take every 2 pixels of the 640 resolution, you turn that into 320, then you get a really good approximation of the 256 colors. And even beyond the title screen, the gameplay actually runs in this mode as well. So again, it's using the VGA assets. And well, normally you would never really see anything like this coming out of an EGA card. Now, what's even more cool is if you plug this into something like a Commodore 1084 monitor, the resolution this is running in is the normal 15 kilohertz mode, so it works on CGA monitors. And the softness of the CRT kind of makes that dithering even go away more. And you end up with this, well, frankly, really incredible looking game that other VGA games could do to give a really good approximation of 256 colors on EGA. But for whatever reason, The Attack of the Pesky Robots, which is a newer game, doesn't use this dithering and just runs in the normal 16 EGA colors, which happen to be the same colors as like Tandy graphics or Plantronics graphics, things like that. It's only EGA that really supports the 640 by 200 resolution at 16 colors. And of course, this computer being a regular EGA computers, it can do that. Next up, we're going to try Sylphid, and this is another game that actually runs in EGA 640 by 200 and it uses dithering. Now, this game also is pretty good at running on really fast computers, and it can also run on really slow computers like this and should have good performance. It has really good music, so if I plugged in a sound card into this thing, which we could do, of course, because we have ISA slots, then this game would sound really good, and I think it already looks pretty good for what it is. And look at the date, 1988, also kind of a contemporary to when this machine came out. There's the PC speaker rendition of the theme for this game. It's kind of poor. We'll skip over that. There's no volume control on this machine, not that I'm aware of. No, there isn't. So here's the little intro sequence. Now this doesn't take advantage of the dithering the same way that Planet X3 did, where you had that really 256... By the way, this talking here is like unintelligible. It's completely unintelligible. Yeah, the good thing there's a subtitle. There's no way anyone would recognize that. But there's the game, and performance is fine, actually. I mean, the sound is kind of annoying on this game, to be honest. And I'm talking about the PC speaker sound. But it's a good space kind of, I don't know, shmup type game. Is that what this is called? All right, well, I think I've kind of shown that this machine is a perfectly good and serviceable 286 machine, and the only annoying limitation is the BIOS doesn't support those option ROMs, meaning we can't just use XT IDE cards in here to bypass the ridiculous limitations of this internal SCSI controller. It's possible with some trial and error I'd be able to figure out what the maximum hard drive size that this SCSI controller supports in here, but to be honest, whatever, these 231 megabyte images that are on here now are perfectly good. I actually don't know if this hard drive controller supports multiple hard drives. I mean, it obviously supports 2, but does it support up to the 7 that are available on SCSI? In that case, I could just copy that 31 megabyte image 7 times on the SD card, and we'd have, you know, C, D, E, F, G, and so on. But for now, this is pretty good. This is a good demonstration this machine works. I think now it's time to bust out that plasma screen and open that thing up and see if I can do some kind of repairs on it. Here's the top of the computer with the screen still attached. This is exactly how it was the end of part 1. I haven't opened this or checked anything out since that video. Now, there were lots and lots of comments on that first video about, well, bond failure and flat flex failure and all sorts of things. I think a lot of people were thinking that this has a similar failure to what happens on LCD screens, and that may well be the case. Having not looked inside of this thing, I don't know the construction on here. Now, lots of people said, oh, you can use your soldering iron to fix those things. And while that is technically possible, and if we're talking about LCDs especially, because it also has a vertical line problem on a lot of the older ones, while that's technically possible, it's, well, A, not usually easy to do. It can often ruin the screen or make it worse. And also, it very typically is a very short-lived solution. So, for instance, the Game Boy, the original Game Boy is a good example of a system that always gets these vertical lines. And the real good solution that seems to be a good long-term fix and highly repeatable is to just buy a new modern replacement LCDs that they make for those things. That seems to be the easiest fix, and luckily, because that thing has a lot of aftermarket support for it, that is something that's easily attainable and it's not very expensive. Now, I've had some other LCD screens that had vertical line problems, and it was simply caused by a zebra strip, which is this little piece of rubber basically that's conductive only in one orientation, and that's squished between the LCD screen and the PCB. And that compression of the zebra strip is what transmits the signals from the driver IC on the PCB up to the LCD screen. So if you have a bad connection on the zebra strip or is starting to corrode, well, that's when you start to get the vertical lines. Those zebra strips are still available, and I think you can just replace them and you can cut them to length and put new ones in, and you can crimp the case down of the LCD to squish it even harder, and you can usually get things working again. And I think Shelby on Tech Tangents had a similar LCD fix to that. I can tell you right now, even before we open this thing up, that there are no zebra strips inside of this thing. This thing is a gas plasma display that A, runs at like 200 plus volts, and B, has a bunch of these ribbon cables and driver ICs that are soldered onto the panel. And if those flat flex cables start to degrade, or those connections start to have problems, or the driver ICs start to have problems, then things really start to fail. People suggested as well that, you know, poking around on the board, like pushing on to try to figure out where the bad connection was, could help. But again, 200 volts this thing runs at. This is not running at like 20 volts or 5 volts or whatever. So if you touch that in the wrong spot, you're gonna get a shock. And I really don't feel like getting a shock trying to work on this thing. But with LCDs, definitely when you're trying to figure out if there's like bad connections or the zebra strips, you know, pushing on it physically is a great way to try to figure out where your problems lie, and then you can focus on those areas. It's just not going to be as easy with a gas plasma because we're talking about high voltages and a different construction method for these screens. Maybe when we pull this thing apart, we'll see a model number on this panel and we'll be able to find a replacement for it. Although I do have to say that lots and lots of people in the comment section also said that they had, well, some people actually had this exact machine, others had Toshiba variants, and it seems that the early versions of these machines have this particular problem with the vertical lines. It seems to be an extremely common fault that takes these machines out. People put them out of service, and I had numerous people mention that they put their machine away into storage and it was working perfectly. And then they took it out years later, and this was stored indoors, very climate controlled, nice environment, and then it had horrible vertical lines as well. Anyhow, I've certainly been talking about a lot of theory here and not a lot of action. So let's get this thing out. And that's going to be the first trick. Because if we take a look at this thing, there are no exposed screws anywhere on this thing, on any side of this case. What I think is going on though, is that underneath here are some screw holes. And if I push on this plastic sticker, I can feel that there are some holes back there. So I'm going to try to peel that up, and I hope I don't cause too much unsightly damage on here. I can apply a little bit of heat, but I'm wary of that because it can melt the plastic here, and this textured plastic can get ruined, or you can get these sort of like shiny spots and whatnot in it. So I'm going to first just see if I can peel this up using like a spudger or something, and we'll go from there. Okay, I just got my blade under there, and I was very careful about that. Okay, now I'm going to try to be careful here not to bend it because it can crease the plastic. So I'm sort of pulling on it. And indeed, take a look at that. We have some screw holes under there. So my idea is I can take those screws out, and once they're out, then maybe this entire plastic lid kind of like cantilevers out and has clips on the rest of it. Okay, there we go. No damage. The screws should just come out relatively easily. I'll just get something to hold them there. Hopefully they're all the same length. Yep, that one seems the same length as well. And these are going into some kind of metal inserts because they are not just plastic screws or sheet metal screws, they have fine threads. Now, as for this sticker, I'm going to say that does not have anything underneath it. So those screws are out. Let's see if we can get this thing freed up now. I'm going to say without a doubt, there are going to be some kind of clips around the edges. There are no obvious marks as to where those might be though. All right. We're making progress. Unfortunately, the camera's not very wide angle, so I can't really show you how this goes on. But it seems like there's a clip up here, and that should probably be exactly the same on the other side here. I'm just going to keep working at it. All right, and I just sort of jiggled the front panel here, and it just came free. Looking down at the inside of the front bezel here, so these are for the brightness contrast control and the LEDs here. We'll just get those unplugged. And what that leaves us with is the plasma display. Something's going on where the flat flex, which is right here where my finger is, bonds to the glass here. And this is kind of interesting. Take a look at those conductive traces. Does that not look like some kind of corrosion or something that might be inside? Now, the lines specifically were kind of in this area, or maybe they were across the entire thing. But that does not look good, and that is on the glass itself. Now, looking at the bottom of the glass panel, though, we do not see that same distortion. We do see the fact that there's some kind of a glass, I don't know, like protector or something that's on top here, and it was kind of haphazardly attached, because notice that is actually not on there exactly straight. This is like some kind of double-sided tape here. So I don't know, has that shifted over time? Maybe. There were also several suggestions about what it would take to swap this out with an LCD panel. Well, as you can see, this is huge and thick inside here, so there's plenty of room. Problem is, though, is that the size, I think the size is a little kind of unusual. Yeah, it's about, well, it's about 9.6 inches. And I'm just looking at the active area, which is this lighter portion right here. And you know what's really similar size to that? iPad screens. And it's pretty easy to get iPad 9.7-inch LCD panels, and they're 4x3, they're 2048 by 1500 something resolution, and there are drivers for them that take HDMI input. So it would technically be possible to take an RGB to HDMI and then hook that up to one of those iPad LCD panels. And because the RGB to HDMI is so flexible, you could actually apply an orange palette to it, so you could get a very good simulation of the plasma screen. It would look far better, really bright and high contrast, because we know those like retina screen iPads actually look really good. Now, I will add the caveat that while that conversion is actually possible, I'm not really a laptop person, and nothing about this laptop is particularly special to me except for the plasma screen. So replacing it with an LCD screen, while it would work, it doesn't really feel authentic. I would want this to be working with a working plasma screen, not some kind of fake simulation of one. Anyhow, the next step definitely is, let's try to get this panel out of here. This chunky heavy metal here seems to be just structure for the screen. I don't think it's actually part of the screen. And it looks like there are just 4 screws around the perimeter. So let me get these out. All right, with those screws removed, is the panel free? Yes, it is, and it is heavy. There's a lot of glass in here. Wow. Wow, just wow. Look at these driver ICs here. This is a wild, wild thing. Look at these monsters. Absolute monsters. Well, let's get this thing disconnected so we can take a closer look at it. So this cable obviously is the signal cable. This one here is going to be the power supply cable. This one here, I don't really know, maybe brightness and contrast control. It's probably what this is. And there, everyone, is the back of the plasma screen. Plasma display made by Panasonic. Does anyone recognize this particular panel model number? And are these things available anywhere out there? Now, looking at the construction of this thing, it's pretty fascinating. So we have the main driver board here, and then off of it comes these ribbon cables that run to these, well, flat flex PCBs that have these large chips on them. And see these two right here? I can almost guarantee you that these have driver ICs on them as well, and they're folded over. Looking at it at the side profile shows exactly what I'm talking about. Notice there's a driver IC there on this PCB. And then this thing has the same thing going on with this flat flex that's wrapped around. And then it goes right into the glass where there's some kind of bonding that's happening along this top edge, which incidentally is actually the bottom edge, because this is the edge that doesn't look screwed up at all. And if we flip it around to the other side, I think this is where the degradation is happening that's causing those signal integrity issues, which is causing our vertical lines. Now, when we look at this top edge here, you can see that the flat flex comes in, and then there's some kind of a glue here that is obviously used to attach the flat flex to the glass. But whatever's gotten in there, I don't think is going to be fixed by me trying to use my soldering iron on this or pushing on here. I think whatever's going on there is a permanent problem that's pretty much going to be unfixable. Now, in part 1, there was a photograph of one of these computers, and it had a huge section where all the lines were missing. And I have to imagine that this same problem has just gotten much worse on that one than it is on this one. But yeah, this has got to be the problem right here. Now, people mentioned that other potential issues could exist, like you could have corrosion on the pins on the driver ICs here, but this actually looks like it's got this kind of conformal coating on it. You can see it's sort of coated in something here. So there's really absolutely nothing wrong with what's going on this part of flat flex. It all seems to be in that bond area. Now, I guess I'm at a little bit of a crossroad here, because to be able to even unfold this so we can take a look at the backside to see if there's anything obvious with that bond that's bad, we're going to need to unfold these two wings of this panel. But these are definitely glued down with some very strong glue. Just these ribbon cables alone are glued down with something fierce. I can probably break the glue though, if I just pry carefully using my plastic tool here. Okay, there we go. I have freed that one up. And the reason why I did that is I wanted to try to pull this connector off here. All right, so this should pull out. Okay, there it is. Oh, these are the worst cables. I hate these. They can corrode and get very easily damaged. All right, so with that peeled back, Let's see if we can peel this thing back. How is this attached? Whoa, okay. Well, that was just really strong glue there, and it just popped. That really kind of shocked me. It's just a double-sided tape right here on the board, and it's stuck down onto that plastic. Now, with that open, you might be wondering, what's going on exactly with this? I don't really know plasma screen technology that well, but I'm assuming this is a getter, which means if any oxygen starts to leak into the panel, the chemicals that are deposited in this area try to absorb the oxygen and keep them from roaming around inside. If they roam around inside of this thing, yeah, it keeps it from working. Either it's the getter or that's some kind of a grid or something like that. Not too sure. Now, one of the things that's immediately apparent with this flat flex cable, even though this is not the one that's having a problem, the one that's having a problem is along this edge right here, there's no way to get to that. And this structure here, this plastic frame, is actually what pushes down on the flat flex and bonds it to the glass. So the good intentioned suggestions of using my soldering iron on this area, there's just, I don't see how there's any possibility of doing that in a way that would actually fix things. I would like to see if we can notice that the glue along this edge is starting to corrode or degrade. So I guess I'm going to continue peeling back these PCBs here so we can see if we see any problems. Okay, there's the second one freed up. Boy, you have to use so much force on there. It feels like it's actually going to break the whole PCB. And I didn't want to apply heat because you can see the flat flex goes all the way along here. And yeah, that kind of scares me to apply heat. Okay, so we got another one of these over here. And then this little thing right there, you might be wondering what that is. That is where they fill the vacuum in the actual plasma display. But yeah, what are these things? Very curious. All right, so we have these two modules folded out of the way. I'm holding them out of the way. Whoops, that one really wants to pop up again. Let's put the screwdriver like that. I have this ribbon cable disconnected, and this is obviously adhered down with some mega force. I don't even know how to peel this one up. I can't get my fingers in there because there's this plastic frame in the way. I can't apply heat because the glass is on the other side. I assume they use this incredible double-sided adhesive here that even after all these years is so strongly adhered. Yeah, I don't really know what to do here. I think all we're gonna see, well, I don't think we're gonna see anything because this frame here actually goes underneath this whole area. And I can see it goes right up to there, and then this is folded around. So the best we're gonna see when it comes to the glue is actually what we see right here on the top already. Now, hopefully this is focusing, but the flat flex actually goes in that cavity down there, and that's where it's bonded to the glass. So this black stripe right here, which I think is out of focus right now, is that bond as far as I'm aware. Or maybe the bond is happening right here. Yeah, I'm not totally sure. But to get to the bottom of it would require complete and utter disassembly of this entire panel, including removal of this frame here and, well, everything, so we could try to see what exactly is going on underneath there. When we look through the glass on the front side and we see these sort of gold color traces, this is actually on the glass. It's deposited right on the glass, and I actually, looks like I just scratched it a little bit. Oh no, that's just a little bit of dirt there. And in that bonding area, the flex cables must be exposed, so there's no solder resist on it like you see right here. So there's the bare exposed traces. And then they're aligned with these marks on the glass, and then it's bonded with some glue or some kind of method that it's not really exactly clear to me. And whatever glue is that's on here that's holding the flat flex onto the glass, which isn't squishy, it's very solid, obviously has started failing. And that's letting some kind of corrosion or moisture or something into this area here. And it seems to be corroding not only the traces on the glass, but also in the bond area. So I don't think I'm gonna go any further with this plasma display. I'm gonna cut my losses now. I'm gonna put this thing back together. Hopefully I can get this thing reassembled and hopefully it works as good as it did or as bad as it did before. I fear if I go any further with this, that this thing will be irreparably damaged and it won't work at all. And I think the only hope would be for this machine is to find another identical panel to this, or one that is compatible, has the same physical dimensions, the same interface connectors, and replace it. I'm just gonna do a jump cut here and try to get this thing back together, and we'll plug it in the computer and see if it still works. kind of back together, and I don't have the bezel on. That means we can poke around the edges of this thing. As you can see, it's pretty much working, well, as it was before. Now, when I first powered this up, it was actually far worse, and it was like kind of a rolling image and all sort of screwed up. I had to remove the panel and then poke around. I used gloves, of course, while I was doing that because I was afraid of the 200 volts that are back there. It turned out the ribbon cable that goes to the top driver board here was the problem. I just wiggled it around and then the picture stabilized. Now, we have, of course, the vertical lines just like we did before. And one thing I did notice is that there is some slight changes when I push on the glass right in this area. So right here, I don't know if it's coming across in the camera, but there's a line, for instance, right here, which kind of comes and goes, and right there, same thing happening. It just pretty much confirms that it's definitely a bonding problem on the glass here. And I think, unfortunately, as we saw earlier, there's all that kind of corrosion along the top edge there. I don't think there's really, much we can do about this, unfortunately. One thing I'm also noticing about this particular panel is that it's really, really dim. I have a feeling this machine was used extensively for a good number of hours. And what's kind of amusing is on the bottom here, these brightness and contrast sliders actually have like a center indentation, like where it wants you to set the screen brightness, for instance. And when I do that, well, on the camera, it looks okay, but it's very hard to read. And it's really quite dim as well. I have to really crank the brightness all the way to maximum just to even get an image that's even somewhat usable. Now, I don't know all the mechanics and the physics that go into making a gas plasma display like this, but I don't doubt that this is no different than a CRT, and it will wear out through usage. So the more you use it, the dimmer the image is going to get. The lines aren't from wear. It's just the dimness, and you can actually get burn-in from my understanding as well. I don't see any burn-in, but I just witnessed pretty crappy contrast ratio, and things just don't look super good. Well, the lights are flickering down here in the basement. It's very windy outside, and we're having a little bit of an ice storm as well. So let me just fiddle. Oh, okay, so this is like a contrast ratio. So in the middle setting here, the black is pretty washed out, but if I turn it all the way to the left, that's a little bit better of an image. So let's hit the control and tilde to get the menu that we couldn't see before. Oh, look at that, there it is. Hopefully it's in focus with the camera, but we have a palette number, and looks like you can use the arrow keys to select which one you want. Change pattern, home and change shade, cancel, save, defaults, select palettes, F1 through F10, save palettes, and looks like also 400/350 line. And now if we push the different F keys here, it is changing the entire palette that's visible there, which I guess allows you to pick things that are hopefully more visible depending on which program you're using. And if we do change pattern, home and end, oh, it's got this dithering. I have no idea if that's coming across, but I am pushing home and end right now, which is changing the pattern, so to speak. Very interesting. So I guess that's one of the ways that it is able to display more colors than probably 4 shades is all this panel can actually do. So it's using dithering. So remember when we took a look at the EGA card, there was an extra CPLD looking chip. I bet you that is doing this pattern stuff that the panel can do here. So if we hit Alt and the tilde key, then that will cycle through the various things. I guess the beep told us we were at the end. Let's run the DOS program edit here. And we'll do the same thing. We'll try to cycle through the palettes here. Oh yeah, there we go. Look at this. So I guess you just kind of do it until you find one that's kind of readable. Let's run Outrun on here. I mean, it is doing some kind of scaling, I guess. Let's see here. Can I bring up the menu? No, I can't change palettes or anything like that while we're in the game here. I was assuming that this game would not take up the whole panel, but it seems to be taking up the whole panel. Unfortunately, the color palette is such, though, that this is not particularly readable. Some of the lines are actually kind of going in and out a little bit. So there we go. So the road to color doesn't look great, but hey, you know what? It's better than LCD at the time, which would have looked like absolute garbage. All right, well, this computer seems to be working as well as it was before, so I'm gonna put it back together and get the shrouds back on the power supply with all the fans reconnected, because the power supply, by the way, gets really hot without any kind of cooling on it. So it's time for another jump cut. S5200 is pretty much back together, and I do have the EGA output plugged into the RGB to HDMI. Let's power this on. Now, it obviously has some kind of a sense circuit, because when the cable is plugged into the RGB to HDMI, the video only comes out of the EGA port on the back of this machine. It doesn't come out of the panel at all. So this thing does not support dual screen mode at the same time. Now, I do have the palette program running there, and we got that red background like we did before, but if I push Alt and tilde now, it switches between the displays. So you can go between the external display and the internal display. And I think at this point, with me loading up Arkanoid here, so there's that Taito splash screen, there's not really much more to discover with this machine. I think I pretty much delved into all the nooks and crannies that makes the Samsung S5200 the Samsung S5200. And with that, that is going to be the end of the Samsung S5200 video series. I can see the comments now. There's going to be a bunch of people who are disappointed about the fact that this plasma screen is not working at this point. You all saw how much these replacement panels cost. At least these days, they're like $500, $600, $700. And for untested ones that probably were pulled out of machines like this that were sent in for e-waste a long time ago. So I wouldn't be surprised if all of those screens that are floating around out there have the same exact problems of these. And unfortunately, I was trying to look through some pictures of some listings for different screens I saw to see if any had close-ups of the bond area on the top edge of the panel, and none of them did. They were all pretty much cropped or way too low resolution to actually make out if we could see that same damage along the top edge. I am really curious, if anyone has a machine that has a plasma display like this one with the same part number as this Panasonic screen, does yours have lines? And if it does it also have some of that damage along the top edge? It kind of has me thinking that that damage along the top edge specifically came from perhaps heat over time affecting the adhesive used along the top edge, because it's certainly not affected on the sides or the bottom, and heat obviously rises. And just from the little bit of time that I was running this computer, the screen's actually somewhat warm. So I could imagine after hours and hours of operation, that screen might heat up quite a bit, and then, well, that top edge maybe took the brunt of that heat and degraded over time. So I hope you found this video series interesting. I certainly enjoyed digging into this machine, and it's kind of cool that it works. Here are all the bad parts that were from this machine. Really, we just had the bad diode, the bad switching transistor from the power supply, and then we had the one shorted tantalum. Oh, and then the fuse, of course, and then the bad battery. The battery is totally understandable. The fuse did its job. And really, I think the entire problem for this machine, besides the screen issue, came from this transistor that shorted in the power supply that took it out. As I mentioned before, I'll upload the palette program along with the ROM images from this machine up to archive.org. So if anyone wants to poke around and check out how those work or whatever, you can do so. If you enjoyed this video, I'd really appreciate a thumbs up. But if you didn't, you know what to do. Hit that subscribe button. Thanks to my patrons. Their names are scrolling up the side of the screen. They get early access to videos, all the other good behind the scenes stuff. And I'm glad the power stayed on, because yeah, it's been pretty rough in Portland for the last week now when it comes to the weather and power outages and wind and rain and ice storms and all that. So I'm really happy that things have survived. So with that said, stay healthy, stay safe, and I will see you next time. Bye-bye.